Good morning, girls, and I'm about to present to you the lesson for Friday the 26th of June, and this is mainly directed at the girls in my class as well as the girls at home who are joining online. So if you're in another teacher's class, you're welcome to listen to this or watch this video, but please make sure that you followed your own teacher's instructions in terms of work that you've had to do and where you are. Okay, so according to the instructions sent on the WhatsApp group, you should have already read through page 85. So you know about proving lines that are parallel, proving lines that are perpendicular, and proving lines that bisect each other. And there's a useful table on page 85 that basically gives you tips on how to prove that a quadrilateral is a specific type, whether it's a rhombus or a trapezium or parallelogram or whatever the case may be. All right, so I would suggest, if you haven't read that you go through that, make some notes, because those are valuable tips for the examples that follow. Example 8 on page 86 of your textbook. Parallelogram TIME is drawn on the Cartesian plane. Determine the coordinates of E. Right, so from the given information, and you need to also be able to apply your knowledge of quadrilaterals, in this case a parallelogram, that the diagonals of the parallelogram bisect each other, which means that P is the midpoint of both line IE and TM. Right, so in order to calculate the coordinates of E, we're going to start by calculating the coordinates of P, the midpoint of TM. Okay, so the coordinates of P being the midpoint means that we add the two x values of T and M, so 0 plus 3 over 2, and the two y values, so 2 plus 0 over 2, and that simplifies to 3 over 2, which is 1.5, and 1. Okay, 2 over 2, which is equal to 1. Right, so now for point E, which has x and y, which we're looking for, we know that the P is the midpoint of EI, all right, because of the properties of the diagonals of a parallelogram. So we're now going to say that the midpoint x value, so in other words xp, is equal to xi plus xe divided by 2. All right, so let's substitute in. We've got the x value at at xp, which is 3 over 2. So 3 over 2 is equal to the x value at I, which is 5, plus the x value at E, which is x, that's what we're looking for, over 2. Right, the denominators are the same on both sides, so we can eliminate them. So we get 3 equals 5 plus x, therefore x equals negative 2. Now for the y coordinate, we do the same. So the y coordinate at P is equal to the y coordinates at I plus the y coordinates at E divided by 2. Right, so the y coordinates at P we've already worked out is 1, and the y coordinates at I is 5, plus y, because we don't know what the y coordinates at point E is, divided by 2. Right, multiply both sides by 2 to get rid of the denominator, so we get 2 equals 5 plus y, therefore y equals negative 3. All right, always conclude, therefore the coordinates of E, which they've asked for, are negative 2 and negative 3. All right, example 9, also on page 86 of the textbook. DEFG forms a rhombus with vertices D, given as negative 1, 1, E, coordinates not given, F, 3 and 5, and G, coordinates not given. Right, question A, find M, the midpoint of diagonal DF. Okay, so this is quite straightforward because we have both the coordinates of D and of f, so finding m is not too difficult. Right, so the coordinates of m we will get by adding the x values of f and d. So we're going to have 3 plus -1, which is 3 minus 1 over 2, and 5 minus 1 over 2. So the coordinates of m, the midpoint, is 3 minus 1, which is 2 over 2, which is 1, and 5 minus 1 is 4 over 2, which is 2. Moving on to question B. Determine the equation of diagonal EG. Right, so because it's a rhombus, you must know your properties of a rhombus in that the diagonals bisect each other at 90 degrees. Okay, so we're going to start off by saying that EG is perpendicular to DF, which means that the gradient of DF times the gradient of EG is equal to -1. All right. So remember, we're looking for the equation of EG. So we need the gradient of EG, and we need one point. We already have a point. We have the midpoint, which is answered in question A. And remember, I've told you more than once before that these questions generally follow on from one another. So if they ask you for something in A, you generally have to use that solution in B or C or D or any subsequent question. Okay, so let's substitute in what we have. We've already got the coordinates of D and F, so we can easily work out the gradient of line DF. Okay, so the gradient of line DF, let's substitute into the equation that I've put there for you, is as follows. We would say 5 minus -1, which becomes 5 plus 1. That's for the y values. And then the x values are 3 minus -1, which becomes 3 plus 1. Right, times the gradient of EG, which is what we're looking for, equals -1. Right, so the gradient of DF is 6 over 4, which is the same as 3 over 2. And now we just need to divide both sides by 2/3 to get a gradient of the gradient of EG is equal to -2/3. That's dividing -1 by 3 over 2 gives us -2/3. Right, so now we have our gradient of EG. Remember, because your diagonals of a rhombus bisect each other at 90 degrees. And so now we can move into doing the actual equation. Okay, so we're going to use the formula y minus y1 equals m into x minus x1. And substitute the coordinates that we worked out up here in A, the m1 and 2, the midpoint 1 and 2 of line DF, and the gradient that we've just worked out, which is -2/3. Right, so substitute that in. So we're going to have y minus 2 equals the gradient, which is -2/3, into x minus 1. Right, let's multiply through. I know I'm going to take this -2 over, so I'm not writing it for now. So -2/3 times x is -2 over 3x. Then -2/3 times -1 is +2/3. Take over the -2, and we're going to add 2/3 to 2 to get 8 over 3. And that is then the equation of line EG. Alright, girls, so now you can continue with exercise 4.6. I know that I gave that to you yesterday, but 4.6 is more relevant to the examples that I've just done with you. Not that it's new work, but it's just a refresher of concepts you've learned before. And once you've done 4.6, please move on to the examination focus exercise on page 88. That is a really, really in-depth and excellent exercise for preparation for your exams. Okay, so do as much of it as you can. The higher mark you want to get, the more you should do of that. We're not prescribing a minimum amount of questions that you must do from that exercise, but please, if you want to do well, do as much as you can from that exercise. Enjoy the rest of your day.